I built an automatic tool changer for my CNC router, and what it does is simple. It switches between the tools that are used for making a part automatically. I don't have to do anything anymore or babysit the machine, which is amazing. I've also used it for a couple projects already, for example a new Spoilboard or this height adjustable computer arm, which now is my operator console. Let me tell you, now that I've used it for a couple projects, I can never go back to manual tool changing anymore. This is just so nice. This was probably the most difficult project I've done so far. It challenged me in every single way. Design, machining parts, assembly, software, troubleshooting and budget. But going through all of that, for me, was pure joy. With this video, I want to show you everything that went into this, so get comfortable, grab a snack. It's a long project. You can tell by the length of my hair. In the beginning of this project, it was like this, and now we are here. Hey, it's me from the past, and if everything worked, you could just see the finished tool changer, but right now, it's not done yet. I have to start somewhere, but how? How would you approach such a big project? Step 1, buy an automatic tool changer. That's easy. Step 2, buy some tool holders and make a tool rack. Step 3, mount the tool rack on the machine. That's the simplest arrangement, but it also wastes the most space. I used the current spindle to demonstrate. The machine is moved all the way back and about at a position where I could pick this tool holder. And when it's done that, it needs to move forward right up to here, because when the Z-axis comes down and it would still be back, it would crash into the tool magazine. That cannot happen, and that distance is lost as usable work area. I don't want to lose it, and the solution has been done many times. Make the tool magazine movable and move it out of the way with a pneumatic cylinder when you don't need it. But of course, there's a big problem number 2. I have 3 controllable outputs on my CNC controller. One I use for the dust collector, the other one I use for compressed air, and the third one I need for the tool changer. So how would I move the tool magazine when I need to, without being able to control it? My conceptual solution was to compromise and give up 20 to 30 millimeters of work area and couple the tool magazine mechanically to the gantry with some kind of lever. So the machine moves a little bit and the magazine moves a lot. Easy, except it's not.
Then I spent a good amount of time at the computer designing a tool magazine with this concept, and then I spent even more time making this animation, so it's fun to watch. When the gantry now moves back in the last 25 millimeters, it engages with a lever on either side, and that will push out the magazine. The lever ratio here is about 5:1. There are tons of custom parts and also a custom spindle mount, which allowed me to squeeze 14 tool places into the magazine, and that's the first part I'm going to fabricate.
I bought 2 pieces of stock because I didn't expect the first try to work, but it did.
The hole I'm drilling here acts as a starting hole, so I don't have to plunge mill. I tried to choose relatively conservative cut settings, which sounded good at first, but then... beautiful. However, it still worked for roughing. The finishing pass then went great, as well as milling the center holes. And the best part is adding a chamfer, which mimics a more professional look.
Machining time was, I guess, about 40 minutes. Cleaning time will be probably 4 hours. The part looks pretty good. I think I made the chamfer a little big, but does the changer fit? No. Well, then let's make the holes bigger. Very nice. The important features are done, so the holes and this surface. Now I can flip the part around and finish the other side.
From the second side, I just had to remove some thickness and finish the contour.
The CNC machining of this part turned out great and accurate, but it also needs some threaded holes.
Here, 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 there, and there. The clamping hole starts with a through hole, then the hole size for the threads, and then cutting the threads. With a level box, I aligned the part in the vise for the remaining holes. They are all just straightforward threaded holes, and did you know that everything works better when you stare at it? The most nerve-wracking part was cutting the slot at the table saw, which turned out to be the easiest. It cut through it like it's nothing.
That worked really well. The slot turned out great. Let's see if the spindle still fits or if the hole collapsed. It didn't. I didn't expect any different because a hole collapsing when you cut the slot is a phenomenon with flat stock because of its internal stress. That's why I bought cast plate stock for this, which has a lot less internal stress. And now, with the one turn of the front screw, the spindle is locked. Fantastic, the hardest part to machine is done and a success. Time for the wooden parts.
I prepared a bunch of raw pieces, flattened the machine table and started cutting. The general routine was to start with holes, which allowed me to screw the part down and let me machine the outer contour as well.
For all parts that get machined on both sides, I also machined these holes for alignment pins into them, and I also machined the holes with according spacing into my machine bed. And by now using 2 pins and setting the piece on that, I know their exact location, and by using one of the pins as XY0, I don't have to measure anything and can just run the program.
I didn't record much of that because it's repetitive and boring, but here's a too close to focus glamour shot. And just like that, I got all pieces necessary. Actually, a full workday and even longer to program all the parts. Then also some middle parts and cutting the linear rail in half.
So many machine parts and a bunch of other stuff I just can't explain now. You will see during the assembly what all this is for. But during the design of all these parts, I got a bit carried away and made an almost wireless 3D probe. Do you think this is worth making a video about as well? Now let's do the fun part, the assembly, which actually starts with disassembly.
This is my automatic dust shoe. I made a video about that as well. Check the video description.
First, the spindle mount gets screwed to the Z-axis, and I think I need to drill the holes in place because I don't want to unscrew all of that.
To ensure I drill straight, I used my dad and his point of view from the side. A chamfer always makes it look better.
That went better than expected. The hole size now is bigger than what M8 needs, but I wanted to make sure to have enough tolerance for everything to fit and also to have room for adjustment later.
If I didn't screw up, the assembly of the wooden parts should be easy.
The alignment of the linear rails is critical because when they are not parallel to each other, they will start binding. So I machined these parallel edges onto here, where I pressed them against when I screw them in place.
Hey, could you please stop judging my professional angle grinder heat treatment rails?
For the blocks, I also have a machined edge on one of the sides to align it against. On the other side, I left a small gap between the machined edge and the block. They are not touching, so the spacing of the blocks is given by the linear rails, and this should ensure that nothing's binding. Looks good.
Then screwing together the rest of the magazine. It's basically a long box that seems unnecessarily complicated, but it's required to ensure it ends up straight because the plywood isn't by itself. Better double check the dimensions.
Oh shit, this is the wrong size.
But now I can confirm, the new spindle holder works. Then adding more parts to the assembly. I also found a neat way for securely mounting a bearing while staying low profile with an aluminum tube and a countersink bolt. The string is for the retraction mechanism and sits in kind of a pulley. All fits turned out well, and this is how the 5-to-1 lever mechanism works.
Sweet.
The strings allow me to adjust the pre-tension on the springs.
One thing I really didn't know if it would work is the spring retraction system, so let's see. Yes, it works.
Lastly, some covers for the sides and a lid on hinges. Soft close is totally necessary, but I had them left over. And there it is. The assembly now gets mounted on the machine table with a specific overlap so the gantry engages at the right position.
The gantry will engage with this mechanism at this bearing with this special shaped piece. And as it moves back, it will push on this bearing, first a little down and then back. And this pulls out the magazine. These pieces get mounted at a specific location on the gantry. And to locate the screw hole positions, I made this template that aligns with 2 of the existing holes in the gantry. Since I don't know the exact final location now, there's still room for adjustment.
On the other side, it was more awkward with all the cables in the way, and the piece needed a cutout to clear a cover.
I haven't adjusted anything yet, it's just kind of in a middle position as it is in the 3D model, so it should work. Let's see. It does. And back. Works as well. This is as far back as the machine will go, and in this position the magazine should be fully extended. It's not quite, but that's okay because I built adjustment into basically everything. I can do that later, but seeing this work now, I'm confident that I can go on with the rest because all of this was more or less the fun assembly part. And now comes the rest. Oh yeah. You may remember what I said in the automatic dust chute project. Alright, everything is in the drag chain, and if you take a look at this, I couldn't fit any other wire through there even if I wanted. Well, now we're here, and this air hose needs to go through there as well.
This actually turned out not to be too bad.
Looks like there was some more room.
The hard part was routing it through the top part and required a good hour of yelling and crying. Let's not even go there and jump right onto the adventures of the electrical box.
In terms of electronics and pneumatics, I need to add this valve for the tool changer and a relay that goes along with it. And I'll also switch out these 2 relays with these 2 solid state ones because they gave me some trouble. The wire mess in here is terrible and I'm about to make it even worse.
It's hard to film this stuff while I also have to figure out what to connect to where, but in the end it only looks complicated and was relatively straightforward. I also added a step-down converter and adjusted it to 12 volts for the tool sensor and to light up some buttons.
I told you it would get messier, but anyways, I have this wire which is connected to this relay, and if I touch any ground with it, it will trigger it and then switch this valve. Since everything metal is grounded, I can just touch the box and it switches. Great. And the second relay is connected to these 2 wires and we'll switch this valve now for the tool changer. And with some pressure, it's tight and works.
Getting this mess organized is a lost cause, so let's mount it again to hide it. The 2 valves I then double-sided taped to the outside. And after all that, the covers can go back on. However, a few of them still needed some modification to clear the new spindle holder.
There are now also a bunch of wires coming out of the machine, and I plan on making a operator console and give it some features, and that's what some of these wires are for.
To connect all of this wiring, I mounted a controller, a small electrical box and a bunch more stuff to another panel. That's all boring, so...
Now for some testing with the controller. The controller output for the compressed air valve is on this pin 3. It's off right now and nothing happens. But when I turn it on and connect again, it switches. Perfect. The output for the tool change is on pin 4. Nothing happens. Let's turn it on. Now it switches. Perfect.
This works, so my automatic dust chute can also be mounted again.
Now finally the part I've been waiting for, connecting the spindle with the changer. So the way this works, the spindle has threads and a taper as usual for collets, and this changer is made for this kind of spindle and has the same threads and a taper piece inside it. And then you just screw them together. First removing the valve.
It's a fitting.
And replacing it with this pin that will lock the spindle. Then I lock this spindle and screw them together. Then I tighten this ring, remove that pin again, and now they move together. Reinstall the valve.
It's a fitting.
And that's it. This now goes into my spindle holder and tightened down. This spindle setup should also be stiffer than the old spindle with the quick tool changer, because this only has a set of bearings in the front right here. And this now has the same set of bearings in the front, but then also a set of bearings in the changer. Should be better, we will see.
Oh yes, this will make a huge difference. You will see in the end.
One part I forgot to install is this pretty complex 3D print, which is a new set of compressed air nozzles around the spindle. Here is the air connection, and everything inside here is hollow. And it also holds this proximity sensor, which tells if a tool is installed in the spindle or not.
This tool sensor is what gets the 12-volt supply.
Everything necessary is connected. Time for a test with air. I wired up this switch to the tool changer valve, and if I press it, the clamp should open to insert the tool holder and close when I release it. And it works. With the tool sensor active and being on right now, it tells the machine that there's no tool installed right now. When I install one, it turns off and tells the machine that there is a tool. Very important information. With all that done, I can now go on with the magazine. And that started with clearance issues with the covers. So I had to take most parts off again, remove some material and assemble it back together. But now I can start aligning it. For this whole system to work reliably, it's extremely important that both these brackets on the gantry interact simultaneously with the magazine.
And now, facepalm time. What's the best thing to do when doing critical alignments to your months-long project? Crashing it. Even better is getting it in video. I'm still surprised I didn't start cursing, but the panic was high, let me tell you. At least nothing major broke, but still required another 1.5 hours to fix. Let's try again. Right now the magazine doesn't move out far enough, and it's also not hitting its end stops. And it also looks like it's slightly skewed, because when I move forward it sometimes gets stuck. Like now. Adjusting the end stops is easy because it's just a screw on either side. And to precisely adjust the position and rotation of these pieces, I made this jig with 3 screws that fits again into existing holes in the gantry. And then came a good bit of I have no idea what I'm doing or what I have to do, but eventually I figured it out. And after half an hour back and forth...
Right now I can tell that the bracket here is still too low and too far back, because when I move to the machine position of 25mm, the magazine shouldn't have moved. But as you can see, it already moved quite a bit.
And then I got the hang of it.
I think I got the position of the brackets now right, because it seems to work and the magazine doesn't get stuck anymore. Cool. Next I can adjust how far the magazine comes out. I made the slot in the bracket right here, because I want the end to be kind of a spring. These springs should press the magazine into its end stops, so it's always at the same location and doesn't wiggle around. As you can see, it has this springy behavior. And now I only need to adjust the end stops of the magazine, so this tool holder ends up centered in the magazine place. I did the adjustment for both sides simultaneously.
This time everything was fine, I only lost steps.
I did the adjustment on both sides simultaneously, so I don't get it skewed. Let's check the other side. I can't really measure it, but from what I can see, it looks good as well. With that done, there's now quite a bit of tension against the end stops. Now when I move back, I should hear the magazine getting pushed against the end stops. And now I know it's at the exact same location again. And that actually were all the adjustments, so let's try dropping a tool.
Now listen carefully. This is an actual emotion from an engineer when something works as expected.
Cool.
A similar facial expression looks like this.
Cool. Perfect.
Here now in combination with dropping and picking a tool.
I just did that manually with the hand wheel and a switch. How does the machine do that automatically and on its own? Well, that's the software part of this project.
Don't worry, I won't bore you with code. I first had to trim the spindle and then again measure the position of the first magazine place precisely to tell the software. Every other magazine place is based off of that. And with that, I can create the motions the machine has to make for a tool change.
I've done some testing and debugging of dropping and picking the tools and already got it up to reasonable speeds. Now I have a tool installed in the spindle, want to drop it in one place and then pick up this tool in a different place. First dropping it. And now pick the other tool. And that's it. The code that does that is hard to look at, but pretty simple. It's mainly movements of the machine, so back, up and down, opening and closing the valve at certain times, and reading the sensor to check if something went wrong. The straight movement down into the magazine works great for tools that are smaller than the chuck, but I also have this flattening bit, for example, that's bigger, and this doesn't work. So can I use that with the changer? Well, if I tell a human try to put this in a magazine, you would fill around and there you go. So I only have to tell the machine some specific movement to make this work as well. And after a few tests, this looks like this. During all these tests, I called the subroutines that did all the magic here manually. When there's a normal program with multiple tools, it has to happen automatically. So how does the machine know where what tool is and if it's a big tool or a normal one? Now bear with me, the following is not complicated, but I need 90 seconds of your special attention. I'm using a standard tool table that's built into the control software. And every tool I have gets its own tool number. It also contains additional information like tool diameter and length. I just made these numbers up. The actual lengths are measured by a tool length sensor. I now added 3 columns to this for the magazine place, for an indicator if it's a big tool, and an indicator if the tool is already measured. When I now put tools in a magazine, I can tell the machine with that where that specific tool is. So for example, tool 1 I put in magazine place 1. And since it is one of the big tools, I set this indicator to 1. The measured indicator is automatically set to 0 until the tool is measured with the tool length sensor. Tool number 2 I, for example, put in place number 2, it's a small tool and not measured yet. Tool number 3 could be in magazine place 5, not a big tool, not measured. The magazine place doesn't need to match up with the tool number because it doesn't matter where the specific tool is installed in a magazine. And this also allows me to have more tools than magazine places. I just can't use them all at once. I made up a couple numbers to give you a demonstration. Let's say a program starts with tool number 1, the machine does its job and then needs to change to tool number 4. What it does, it first looks at its current tool number, where it belongs in the magazine, moves to this position, and then if the big tool indicator is a 1, it does the motion for a big tool to drop it in place. Then it goes to the new tool number, looks where it is in the magazine and moves to that place. And if the big tool indicator is a 0, it does the standard movement to pick it up. And that's conceptually it. There are of course more details and special cases that I just don't have the time to explain. For example, what happens if I want to change to a tool that's not in the magazine? But I guess you get the general idea, so let's try it out. I type M6 for tool change and T4 for the next tool number. It's the same example I explained, so dropping tool in magazine place 1, move to tool number 4 in magazine place 8, and the machine picks it up. Works beautifully. I'm also pretty happy with the speed, and you could also hear compressed air, which I use to blow dust and debris off of the tool holders so they are clean when they get installed.
As this is working, next is installing the tool length sensor again. I wanted to mount it permanently on the machine and needed a mounting plate for that, which I turned out of a piece of aluminum. Unfortunately, the cutoff tool broke midway. At least I got my workout. Then drilling some holes and cutting a slot for the cable. I found a neat solution to do that safely with the table saw.
This is probably the best metal part I've made so far. The tool sensor fits, the cable here. Does it really need leveling screws? I don't know, but I needed the bigger mounting plate anyways, and these were just 4 additional holes. And now I can also measure tools again. I optimized the speed of that as well, and not only that, the whole tool measuring will be full automatic from now on because of that measured indicator in the tool table I showed you earlier. So when the machine picks up a tool that's not measured yet, well, it will just do it then and move on. The big tools are a bit of a problem because the measuring happens always in the center of the sensor. And this tool, for example, doesn't have anything in the center, so this doesn't work. I could offset the measuring position for the big tools a bit and then touch off one of the cutters, but I can't guarantee that they are oriented the right way. So it could be like this, and then it touches off nothing. And come on, I didn't go through all this effort and still have to babysit the machine when I want to measure a big tool. There has to be a better solution. Let me show you what I came up with, because it works and it's pretty cool, and then I explain it. It's pretty fast, and what happened? I first probe at 3 specific locations. Within these locations, it's guaranteed that at least one time a cutter got measured. I figure out which measurement that was, move to the same location again, and make another slower and more accurate measurement. Up to the biggest tool I'm using, and with this sensor, this will work every time. Let me show you. I spin this to a random location and start the probe cycle. Again. I don't know why, but the fact that this works and so fast is the best part of this project so far. Now the package I've been waiting for. More tool holders.
Now let's cut something and test the whole system. The first part would be a new tool magazine, because there are some issues with the current one.
With the current design, the tools can't really fall out by shaking, but they can get stuck at an angle, like so. No good. And after a few iterations, I now have this shape, which has a better fit, is shake-proof and tip-proof. Now I was doing one more test off camera and disaster. After the first operation, the air pressure was at about 6 bar, as low as it gets, and the tool change failed. Don't worry, I programmed this in, and when this happens, the machine stops, nothing got damaged. But the whole system doesn't work. And one of the problems is that I don't supply enough air pressure. In the manual of the changer, it says I need to supply 8 to 10 bar. But stupid and naive me just thought, ooh, tool changer. It will work with 6 bar as well. And now we are here. Now, supplying sufficiently 8 to 10 bar is not particularly cheap. I need a bigger compressor, which is expensive. Or I need a pressure multiplier, which is also expensive. However, I got an amazingly good deal on this used one on eBay, and all it does is doubling the input pressure. It works with a stupid simple concept. Inside there is a piston, and the input pressure presses on one side of the piston. The other side of the piston has half the surface area of the input side, and that way the pressure doubles. The real thing has 2 opposing pistons, and with cleverly arranged valves this will work continuously. Since the shopware won't drop below 6 bar, with this I can now sufficiently supply up to 12 bar. And now everything works. Let's finally cut something.
Another really cool fact is that my DIY 3D probe shows potential. Then I started the program and the machine switches to the first tool. It seems like this wasn't measured, so it moves to the sensor before it goes to town. And the next tool. Here the machine waits until I screwed down the piece and removed the clamps so it can be machined from all sides. I really don't know how to show the system working, so I just picked up the camera, recorded and let the machine do its thing. And that starts with a bunch of roughing and just removing material. Here you can also see that I programmed a delay, so the spindle can come to a standstill before it starts moving for the tool change. I programmed more different tools than necessary to see how reliable the changing really is. And there's another unmeasured tool. Yeah, and then it's more or less always the same. Too bad that seeing the finished project working on a part is kind of the most boring part to watch. But one more cool thing to see again is for the second side, because it starts with the flattening bit that isn't measured.
The part is finished, looking great, and everything worked as intended. What a journey.
One more thing missing is paint and the numbers. I of course also machined some more parts because of some collision issues I ran into, and that's also a good spot for my logo. And then I took everything apart again for some paint, covering up all important surfaces of course. On the final assembly, I also added other random bits against chips and dust like screw hole covers and a bottom brush. That however needed a new haircut first.
And now, the project is complete. What a wild ride. I guess I had the idea for this about a year ago. Started working on the design about half a year ago for some time, and now finally seeing it being a reality is, I don't know how to describe it, it's amazing. Especially since it also works. This upgrade made the machine, I don't know, 3-4 times more capable, not only because of the automatic tool changing now, but also because of the increased spindle stiffness with the 2 sets of bearings. And especially this makes it so much more fun to use, because I don't have to be kind of careful with everything anymore. Now, before I show you the before and after of what's possible with this now, I need to talk about one more thing. Making this project and video took a really long time, and it's no secret, it was very expensive. And since I don't have a sponsor for this project, what still allows me to invest all that time and money is your support. So thanks everybody for watching all my videos. But if you want to do more, there are a couple ways you can support me directly. For example, through Patreon, where you can sign up. There you will also get additional content and early access to new projects. You can take a look in the video description. There I have a few affiliate links for most router bits that I used also for this project. And if you buy through that, I'll get a small commission. And the last way is to visit my online shop and buy a plan from there. which is a win-win. So, thanks for listening and let's shred some wood.
This cut surface does not look good. This was with the old spindle and a 2-flute 8mm bit, going 4mm deep and 6mm step over in birch plywood. Now with the same bit I'm using 18mm thick plywood, go full depth, full slot and rapid feed, which is 6 meters per minute.
Isn't this amazing? I mean, it totally overloaded the spindle. No discussion there. It can handle that for a couple seconds, so that's okay. But the cut quality is still fine. No chatter. And that wasn't even a roughing bit, that was a standard one. I guess you can see why, especially this makes using the machine so much more fun. I can use so much more potential of all the router bits now. And I also did when making this computer arm project, so keep an eye on that video and project. And I guess that's a perfect wrap up for this gigantic project. Thanks for watching. Bye.